Welcome to the Plaiground podcast, AI's place to play. Today we have a special guest. His name is Jerome Durussel. Jerome is the lead data scientist at Catapult Sports, an international company that aims to improve the performance of athletes and teams on their jobs. Previous to that, he did his PhD at the University of Glasgow on the developing a breakthrough test for anti-doping in sports. Based on his research, experience, and genuine interest in visualization and data science on both business and sports science, he transitioned from academia to the private sector in 2015, joining the PhD data scientists initial generations here in Europe. Welcome to the Playground, Jerome.
Thank you. Thank you for this welcome.
How are you?
Yeah, no, I'm good. Thank you. What about you?
I'm doing well. Okay, so we'd like to start the conversation with breaking the ice a little bit with a question that maybe it sounds a little bit silly. So, what is your favorite sci-fi movie or book that inspired you more at work, in the work that you do?
Yeah, interesting. I'll maybe disappoint people because I'm not too much a sci-fi person. I definitely prefer more like something theme which is more realistic. I feel like sci-fi movies are. Well, again, I'm sure I will make a lot of enemies while I'm saying that, but it's the filmmaker can make up about anything that they want at any point. Although there is definitely a few good probably sci-fi movies, I'm not the biggest fan of that.
Okay. What about the other type of movies?
I don't know. Well, obviously the first come to my mind, which would be Moneyball. I guess that's probably the thing in sports analytics. Although maybe not. Yeah, there's probably plenty of other better ones, but in terms of like a film that I quite enjoy. But I guess Moneyball is, in terms of sports and sports analytics, is the film that everybody references.
So you are really into the sport, even in the movies world, right?
Yeah, well, that's you said what type of film inspired also my career. So I don't think the film inspired the career, but more after obviously in being in sports and on data science, I need to know, at least I had to watch Moneyball because that's kind of where it was a start. Like most people reference sports analytics as this type of reference in mind.
Okay, perfect. So you make a transition from academia to the private sector, private company. So how was that transition from academia to data science in terms of, what was your trigger to do that? What was the struggle doing that? What was the part that you enjoy the most?
Yeah, no, sure. So maybe a bit about my background. So I did a few things before getting to that job right now at Catapult. But I guess the theme was always sport from the beginning. So at the very beginning, I come from Switzerland, and when I started to study, actually probably what I wanted to become was more a PE teacher. Then slowly during my bachelor's, maybe I'd like to do more maybe around strength and conditionings or a bit more about what if there's a place where I can maybe work around more sport performance. At that point, this is where I moved to Glasgow, completing my master. Again, it was just supposed to be for 1 year just to learn English mainly and complete my master. And then kind of nothing planned, but this is where I started my PhD in molecular biology, but always kind of still applied to sports, as you mentioned in the intro. So the aim was to try to develop new tests to detect doping in sports. So
it was applied to any specific sport or in general?
Yeah, so it was more endurance sports. So because the doping, so what we used as a also was EPO. I'm not sure if you heard about it, but it's the type of
Yeah,
drug that probably Lance Armstrongs and others would probably
sure.
will take. It's trying to increase your red blood cells. So the PhD was actually I had to find volunteers that they were not allowed to compete, obviously, but find some volunteers, give them the drugs, and take blood samples before, during, and after, doing plenty of other sports like exercise tests. And then for each blood samples, I was looking at 47,000 genes.
Hmm.
And the idea was for try to find which genes was impacted by the drug and whether this can be used further. So at that point in time, I was good at Excel, I guess. But
Yeah.
47,000 times 8 blood samples times 40 athletes, and to see which one were changing or not. That's where my Excel skills kind of I was struggling with those.
Sure.
And this is where I started to spend much more time with my second supervisor, a statistician specialized in this type of analysis, and he was
Hmm.
using R. So this is where
Hmm.
slowly I just started my transition. Well, it's not from academia yet to business, but I'll come back to that. But this is more of a transition to more sports, microbiology, and exercise physiology to more about a bit more programming coding.
Sure.
And then again, I'll try to fast forward, but at the end, so we basically found, make it simpler, about 25, 30 genes that were interesting. And so we replicated another study doing a postdoc and focusing on those 35 or 35 genes. And the idea was then, as a proof of concept, can we predict if someone was doping or not based on the changes of those genes? And this is where I started to slowly using some very basic as a proof of concept, but machine learning
Yeah.
applied to those kind
I
of
see.
those data. And to answer your question, then, so that was a bit like the
So
background.
that
Yeah,
was around 2013,
yeah,
2012, 13, 14.
yeah. I completed my PhD in 2013. Started postdoc in 2014, and then I could probably spend more time on that, but maybe to summarize.
Sure.
So the I was a bit, I don't know, find some challenges with internal politics. I guess some academia egos, and yeah, a bit. I know, obviously, as probably you know, academia is not always nice people just of interest of science and interesting things. So there is anyway. So that type of kind of, I don't know, motivate or behavior motivates me at least to look at what was outside academia. I was still like
Hmm.
also looking at what to further do further postdoc all the stuff, but also looking at outside. And
Hmm.
my wife, or girlfriend at the time, but was more like the tech startup industry. And she was saying that, oh, but there's plenty of like people are looking for data scientists, and I know you code, I know you can do that. And I say,
Hmm.
okay, well, I was Googling. And as you said, this is where then I thought, well, maybe I could do that, but I wouldn't mind to do an extra, a bit of either help or learning through this. So this is where, well, we actually spend some time together at the doing a boot camp in Dublin
Yeah, yeah. Good
to
memories.
do
Good memories.
exactly. So that was kind of a bit of transition, or at least the start of looking something outside academia.
Okay, okay. So basically, I mean, I guess when you not give up with academia, but you were a little bit, uncomfortable in the academia and start looking outside. So you found out that you were doing data science at your current PhD, right? Because you
Yeah,
were
did
trying
it?
to
Yeah.
solve a prediction or classification problem of doping or not doping. So that was and actually at that time, probably you were maybe you used random forest, which was pretty famous at that time.
Yeah,
like
no, exactly. So it's something like I necessarily didn't know that was really called data science. I was doing science. I was from collecting data in the lab. So it was my lab coat taking blood from people to actually processing the blood samples, to actually do the microbiology, as well as, because you've done all this work, then I wanted to be also hands-on on the analysis. And so I was doing that. And yes, I did apply some random forest actually on
So talking about struggling, so you mentioned that you study sports science, but then you move to an environment with like a more interdisciplinary environment with molecular biology as the topic. So probably interacting more with biochemistry, chemistry people. So it's like a transition, and now or after that you transition from academia to the private sector. So how do you feel about those transitions? I mean, it's a struggle, but also it's important to be prepared for this type of transitions, right?
No, I didn't find like too much of looking backwards is always you remember the good things and you forget easily the bad thing. I don't feel like it was necessarily a struggle as such. Well, I was always keen to kind of learn new things. So it's not necessarily a struggle. It's a bit scary or you just because you just don't know the world or the other world. So you have to push your boundaries. So you go outside your comfort zone. So that's where it's a bit scary. But I guess luckily I didn't. Yeah, you obviously have some doubts about what you want to do in your life or which job you want to pick and so on. But at least luckily for me, I think that kind of periods were not too long, and more back now in the industry, I think where I was very lucky to find. Working at Carpal, it's an Austrian company, but when I joined, so in total around the world, there was maybe about, it's probably not exactly right, but about 50 people. But in Leeds, so where I moved to get the job, so here in Europe, in Leeds, so we were 6 or 7. So it was very much like startup-like, at least for that type of region. And that's what also what we enjoy. It's like to do a lot of different things, be involved, where you don't have at that point too much politics. You're in every meetings because the whole part of that region is in every meeting. So in that sense, it was good, and I didn't feel also too much. Well, there's a pro and con, so too much more struggle, or I find it easy to be part of that team. But at the same time, I was the first data scientist of the company, so that was maybe also quite challenging in terms of not learning from someone within the company. But at the same time, the good thing is I could shape a bit my job as almost I wanted, or how what was needed.
Yeah. So people listen to you, right?
So that was a good thing. You had direct contact with everybody, with the customers, with all your colleagues, and so you have So that was I definitely found out now, because now at Carpal we are still growing, about 350 people, I think now.
That's right.
Ish. So now. Obviously you can have a meeting with everybody in, but it's much more difficult to just know everything's going on, and you have much more departments, you have more, and for that you need much more clarity about who is doing what, which is another challenge, which you don't have that much of the challenge when you're a startup or a small team.
Yeah, absolutely. And how does it feel when you start up, or when you are in a startup mode with not too many people, everybody's aware of what everybody's doing, and then this start growing, which is great because business is growing. But so how's that process? Because I don't know, I haven't talked about that with anybody, about the whole transition. So I think in your case was the last 3-4 years that has been increasing, not exponentially, but remarkably. So how does it feel?
So it's again, it's a journey. Probably from a very personal point of view, I would probably still always tend to prefer about smaller team. I'm someone, probably back to my background, who I like to do a bit of everything, and not just because I like to do a bit of everything, but I feel this is kind of the best way to, if the aim, probably as a data scientist, but as an employee, to create solution to problems. And typically what we receive as problems typically always are not necessarily well defined, at least in where I work and how I work. And I think the best way to get the best solution is try to also work with a lot of different people, get empathy from different teams, empathy from from the end user, and that's where I'm the most comfortable with, or maybe I prefer. But as you said, so obviously it's good that the company as a business is growing. So but you just need to find a bit your place. So it's a bit more around communication, and it's more about, I guess, also talk about more the velocity then of the project is not just up to you, but it's up to almost how fast or how maybe slow sometimes other part of the business or the departments are, and so you need to kind of catch up. So it just give you, again, it's as long as you keep learning, which I'm still learning with how also a business, or how to also work in a bigger business or a business that is growing. I think still that's quite enjoyable.
Sure, sure. And do you think it's important that you love sports, as I know that it's your case? You like sport, you like practicing any type of sports. So do you think that to be able to work in a sport company as a data person, data scientist, data engineer, or something like technical like that, so do you need to have that passion for sports? Or how that benefit you? How that benefit you?
Yeah, no, definitely would be benefit, and well, that's where then it's a very cool job, because a lot of people also love sports, obviously, and they'll be able to do this as a makes your passion and works. Obviously, that's amazing, and definitely benefits for my work. Do you need to have this? I think it's obviously a plus. You don't have to, because probably also it's a good thing is maybe sometimes to mix people, again, back to cross-functional and more multidisciplinary people benefits. I quite like also someone, definitely I think in a team, if you manage a team, if you're passionate about sports, obviously it means if you're passionate about sports, you probably understand a bit more sports, or you're more closer to what the end user, either the athletes, the coach, or the sports scientist, will need to do that. If you're not passionate, or if you don't know the sport, then it's a bit more difficult. But at the same time, if you don't know it, then it's also something that can give you another light, another angle of something like you didn't think, just because you're so much into it. So I quite like this balance, but you be able, knowing the sport is a plus. But as an example, one of my first projects, and which I enjoy a lot, was with cricket, English cricket, which growing in Switzerland, and I didn't know the sport. Maybe again, I hope I don't upset anybody on listening, but working with top athletes and with the team of England team, so the ECB, and not knowing, but also hopefully I have enough information, background and knowledge about all the sports. I hope I ask the right questions to know enough to create a good solution for them. But that's an example where actually a sport that I didn't know well, I still managed to do, I think, a good project.
Let me ask you. So your focus in the last 4 years, so probably has been broad, right? But I had the feeling that you have been focusing a lot on performance, on the performance of the player or the athletes, and give analytics about that. So how is that? I forget what.
Maybe I can just give you a bit of background. So information about. typically what we do, so we do more, but probably the main thing that we've been doing, myself and my team, is, so a couple what we do, well, we do again more, so we have different solutions, but what we've been working on, especially on our wearables, so it's those small device, GPS devices, and which have also inertial sensors, so accelerometers, gyroscope, that people put on their back, and from the GPS, obviously you get positions, X, Y positions. But actually, most of my work has been using the initial sensors, so accelerometers and gyroscope in the device, and using those input of data to create specific algorithm to automatically detect specific events in sports. So I was talking about cricket. So what there is in cricket then is they were interested about detecting bowling. So that's when they throw the ball automatically. And so that's where then I wrote an algorithm that can run on the device or through the software, that it will automatically detect when a player bowled or throw the ball. Or another one more now, if you talk about that, is football, or I know, soccer. If, I know, like I was, is well, work with an international company. So obviously, I say it's football, but now I'm used to do more. I say more and more soccer with my US colleagues.
Well, I used to do that the same in the US.
So, we created also a way for goalkeeper. So the goalkeeper to automatically detect dives. So how many dives they've done, on the left or on the right, how quickly they go back to their feet. Those kind of things. Or in rugby, automatically detect when they were scrums, kicks, what we call contact involvements, which is when they do tackle and stuff like that. And all this is automatically calculated. So by just wearing the device.
That is impressive. So basically, with the information of the wearables, the accelerometers and things like that, so you can classify events, right? And how accurate can you be on this? Like for example, if I do something that is similar in terms of movement to I don't know, an action, a soccer player action that you detect. So I feel that there is going to be a lot of noise.
Yeah, there's a lot of noise, but that's where like working closely with the client to really understand what they want and how they want it and what is possible. So, for example, for the goalkeeper, so yeah, there is a bit of noise, but actually, well, if you dive, again, what we've done and those algorithms. So we work with top athletes. So that's what we have as an input is kind of again that type of level. We include some also youth players, but it's always kind of either national or very good level athletes, and yeah, so you will pick up sometimes a few, we see false positives, false negatives, so you'll never get 100%. But for example, for the goalkeeper, well, then we can go into the whole discussion about what do we use as verification data sets, those kind of things that I'm constantly been talking about probably for the last 5 years, or it's with kind of colleagues and stuff. But all our algorithm, most algorithms for the goalkeeper is more 90%. I've confidence for more than 90% for sure, and it's probably about 95 and actually 97, depending about. It's probably that type of thing. So for me, then what I just transform this kind of accuracy to a coach or a sports scientist. So I say, hey, either because before, if they want this information, or if you take maybe also rugby. So they have, like, if they want, so to count how many times they've done a tackle during a game or during training. So they film the session, and you have people in the club, video analysts, who would just watch the thing, and then for every player, just tag manually, okay, that's a tackle, that's another tackle, that's another tackle.
I see. So that's the way that you create a training data set, right?
That's what we create, of course, a training data set, but that's what they're currently doing as a club. So, so most clubs are still doing that. So, so if we can, then so that's you can imagine that they can easily spend hours doing this. So then the question is how accurate they need to be, or the algorithm need to be, because again, this is where it's well, I'll come back to that, but how accurate you need to be useful.
Yeah.
Because then also, and then the question is about if it's about also clipping video, you probably want to optimize a bit more sensitivity because people usually don't mind to remove the video clip that was your false positive, but you don't want to miss any. Or, and that's more about down the video track. Or if you want to, what we call more in sports is like if you're using those number just as a number and more load management, so training load management, you probably want to optimize more accuracy. And so that's why it's all this kind of discussion back to also my point earlier. So if you're a small team or if you can access or if you really understand the brief, why and how it's being used, you probably can adapt or develop your algorithm in a way that it is kind of useful to the end user. And,
I see.
Yeah.
I see. So let me ask you one thing. I guess the information that you are gathering and the events that you are detecting with your algorithms are important between other reasons because you can connect that with injuries and with the performance of the players, right?
Yeah, you could, but well, I'll let you ask maybe the next question. But well, yeah, I have a few things about predicting injuries. But yeah.
So how challenging is that from a technical point of view, predicting injuries?
Yeah, so about injuries prediction. So a lot of people probably outside or still maybe in sports will think this is kind of in some way it is the holy grail. But and that's more my opinion, but I kind of a strong opinion that it's not what people probably want. Or before that, there's a lot of different steps that can be done. Because one problem about and there's a few problems around maybe injuries if you think from a data point of view, and I'll explain that also a bit more from an applied point of view. But a data point of view is, well, with injuries, yeah, they do happen, but they don't happen that often. So that's one problem. So and actually an occurrence of injuries, so your data set is already kind of biased or it's not balanced.
It's like fraud.
Yeah, so you do have that. So that you just start with that. And then even why is an injury? So because if you look at the literature in sports, but even if you don't, you can imagine, say, okay, you have what is it called, so soft tissue injuries, or if you have, it depends about tissues that you just get into, pull a muscle, stuff like this by yourself versus, it's a tackle in rugby and you just get bad luck. So I guess so maybe you just want to focus only on the soft tissue injuries, so you just make sure so they are locked properly. Then 3 is, well, human. So yes, there are injuries, but human, and that's whereby kind of, working with humans in performance, it's quite complex. So even if it's a calf injury or, well, is a calf injury the same thing than, a groin injury? Is this in the same class? Because it's probably not that many. So as we know in data science, and probably the more categories you create, obviously the smaller your data set become. And so you're not even less and less so. And then it's about how important is your injuries, because some will be maybe on that how they count is, for example, is how many days of training or game you have to be out. But is an injury of 7 days versus a 3 months injury is the same one or not? So already like just that plus. Again, as we said, so we are dealing with more athletes, so top athletes. So again, we cannot go back to the general population, or you just have to make an assumption whether the general population is the same than athletes. So you do have kind of those problems with already. I feel again, it's not impossible, but you just have to really keep this in mind in whatever we do. And then
sorry, I stopped you.
And well, I could go probably more, but then also I would flip. Well, I could doing more. Probably challenges around kind of data modeling for that. Probably also the input of the data, but then also let's assume we do have or you do have a prediction of injuries model. Probably as you probably expect, well, let's assume it will be a probability.
Mm-hmm.
So here is, well, me or you,
There is a
data
conflict.
scientist, and we go to the code, or you go to, I don't know, you get a Messi or whatever, and just say,
Yeah.
hey, my algorithm tells you that you have 5% chance to get injured today. Then what?
Yeah. How are you gonna handle that
How this will
information?
exactly? So then, well, 19 times out of 20, it will be fine. And then you say, no, I feel fine. I'll play. And then, well, you have only one chance. And how do you use that? So one big thing is before even thinking about, or while thinking, doing things is I think there's two key things is about, well, which is the same, similar, but it's building credibility and trust with
Yeah.
people who have
Trust.
experience in the sport. So if you don't have that, well, you need the perfect model, which I think probably we both know that this probably doesn't exist, or at least won't exist right now. And I feel then, so it's all about like building trust and credibility. And then I think to the answer about injury prevention, I don't think people want actually a model that try to predict injuries. But what I'll try to flip this is the other way around, where coaches or sports scientists, so there's more and more data coming at them. So they are kind of overload, or at least to a certain extent, overwhelmed maybe with data. So I think it's more about, can we at least not remove, but put this kind of more on the side. Anything this is usual. So they finish their training session, they finish the things, you have all the data, whatever, you can spend times of wearables, video, whatever. And anything which is kind of usual, you just put, well, you can go and look at them if you want to, but you just highlight anything which is unusual. You don't say it's injury, you just highlight anything unusual, and you say, hey, this is what with your human brain and all your sometimes 10, 20, 50 years of experience, this is what the data should look like. Does that make sense? And trigger discussion within the department of sports.
Okay.
I think this is where we can help as algorithms try to at least separate what is usual versus unusual for what we record. And then we leave and we just help people to then discuss and save them times, basically.
Yeah, I see. I mean, the trust is a big problem, but that will, with the time, you will lower the barrier, the trust barrier, and the confidence as well. But so what I want to ask you is about statistics. So in terms of tissue injuries or similar like that, so how is more frequent to get injured, in a training session or in a game?
Actually, I'm not too sure. I don't know. Actually,
Like for example, if a player has a game and you have a 90% of possibility of injury because of the algorithm say that, you will have a conflict because the coach wants the player wants to play, and the algorithms say the contrary. But if you are in a training session where you can handle more that conflict, because you can say, okay, rest or go to the gym or get for a massage.
No, and well, not going back to the very, very first icebreaker question, but that's where we're discussing sci-fi. So whether, and that's like, you can think about minority reports about having predictions about of injury, and you have discussions hypothetical discussion with the coach or the player. But yes, that's actually happened in sport, where even like with medics, where you know that someone is, and probably even the worst part is probably the Olympic Games. So an athlete's Olympic Games is every 4 years, and sometimes maybe an athlete who is at almost more towards the end of his or her career, and that's almost for sure he or her last Olympic Games is injured, or you know that it could be fine, but it's probably not likely. Yeah, as a medic or as you probably with any other events, we say no, you shouldn't do it. If you take into account maybe probably the mental health of that person, of that athlete, sometimes you just say, well, have a go, because actually probably to lose or to miss this is probably more detrimental to the health, if you just don't think about just the calf or whatever will break, but more the mental health as also general. Sometimes it can be quite a tough discussion around that. So yeah.
Okay, but I'm gonna say something that is a little bit. I mean, I know that you are a skeptic about this possibility, but the reality, like for example, I'm gonna give you an example. So I'm a Real Madrid fan, okay, and we had in the past and now Gareth Bale in the past that got injured, and you can predict as a fan, you can predict when he is going to get injured. Like probably after this game, he's not gonna play anymore in 2 months or so. So, and the same thing now with Eden Hazard, right? So at the end of the day, somehow humans or fans, which are also humans, they have abilities to predict that or to have that feeling. And how can we cannot do? I mean, I'm a skeptic as well, but for sure, as soon as we have enough data and define best practices, standardization about how to approach the problem, you should be able to find the patterns.
Yeah, there are definitely patterns. That's what I was saying. That's why you can just say what is unusual. The thing here is more about. This is more like almost a problem about betting. So it depends about, again, your level of accuracy, your level of sensitivity and specificity. So you can get it wrong, but you'll probably have the odds about, at some point, obviously, you know that the player would be a bit more likely to be injured than others. You probably know that. And definitely in sports science, you definitely will know that there's trends about, it will increase. But what do you do in terms of, again, back to maybe the question about, so as a company say, no, you can't stop a player to do that. So and this is where then again you have to adapt. But if it's about betting, I don't know, is it more about if you get it wrong, well, you lose. But as long as you get it right enough time, then yeah. So, but that's where then if you just develop an algorithm again which will predict I know you have your 51%. So it's just better than random. Again, that's okay for if you. So it just means there's definitely information there, but again, if you go to your club or to Real Madrid, say, hey, I have my injury prediction model. They say, well, we know that if you train hard one day, you are probably more likely to get injured. Probably the best way to not get injured is to not play football at all. So, or you have those silly kind of things that probably good discussion you will have. So,
well, at the end, technology is just to facilitate your job as a human, as a coach or decision maker.
Yeah.
Okay, so let me ask you about. I know that you love visualization. When I met you, you were a lot into visualization. So how important is visualization and computer vision also in sport analytics?
I'm a big fan of personally, I'm a big fan. It's a personal interest, the visualization, because it allows me. I do also paint and draw on the side of stuff, so that's going to allow me just to use a bit more my artistic, or apply my artistic skills into my work. But I think visualization are very important. If your aim is to obviously pass a message, and especially to non-technical people. Again, back to if you want to build credibility and trust, let's say, up to with athletes and coach, and we are not necessarily all into they want to just have quick kind of answer, and you don't have the time just to go through your whole PhD or whatever, or your whole documentation about your analysis. Visuals are usually, you can put a lot of information into visuals that it's harder to put it in a table. Obviously, they are more engaging. Or if also the aim is to also attract the interest of the audience, just maybe have this cool first. Oh, that's cool visual will attract the audience, and then hopefully it shouldn't just be cool, but then it should obviously have this message where you can play with obviously with visualization, so colors and all different like charts and things, just to make sure what you highlight and what you just put it in the background and tell a story. So yeah, I'm using this a lot. I always try to find it, or to make the difference between data visualization for exploration and explanation. So use it, obviously, all, I guess, data scientists are using data viz for exploration. So plot your data, look at your distribution, try your different things. And again, for us with wearables, so you look at your accelerometers, gyroscope kind of traces, plot this in different ways. So that's all about kind of explorative type of data that I'm using a lot. And then that's where then back to, so as a company, a couple, then try my best to influence the product around, right? So now once we know something, so it's not just about exploration, but we want to explain something, what visuals are best to describe something that we found. So.
Absolutely. So are you? So I see that also there is another visual component in the AI space, which is the computer vision. Yeah, and with the performance of the deep learning strategies that are putting the benchmark above the humans level. So how is that applying into the sports science? Computer vision.
So again, so far my kind of expertise has been more on the wearables type of data. So although again at Kappa we work also with video, so that's also part of our solution. It was more like a side project, not so much me as kind of all kind of tactical, although that's again another part of probably of Kappa. But what at least I've been playing with since actually last December is some computer vision open source tools from Pose called Alpha Pose or different pose tracking. So with any kind of video, it will automatically find your segments, 17-point segments on any kind of humans. And if you apply this for a game or for something like that, it's actually for something open source and like the first time I've been kind of playing.
Actually, when we are talking about athletes, they became or improve their time when they are running or whatever. They need to improve their technique, and the technique it's completely correlated with the pose and the movement, right?
Yeah. So and actually with wearable, I've done also some work with just a wearable in between your shoulder blades. You probably can also tell you a lot around how you run.
Really?
Running. Yeah, I did actually a study with a master students around that. We on a treadmill, so it was kind of more controlled, and but also inducing asymmetry. So putting a knee brace or a heel lift in your shoe on one. So like this you can see so if you have a running pattern and then you just induce an asymmetry, which is back to injury or back to if someone was injured and you have an asymmetry or those kind of things, or an asymmetry could then means something that maybe again is not symmetrical, therefore imbalance and so on. But you can definitely detect those kind of things, and that's kind of useful. Although again, is the more you research in human performance or physiology, usually I'm getting more and more, or I'm trying still to be very humble about, because you can find something like super interesting, but as soon as you find things interesting, you just realize all the things that you don't know, or how much. Actually, even if you're all humans, how much humans are coping in a slightly different way with the same kind of limping putting a knee brace. People will cope in a different way, and that's very interesting from a research point of view. But again,
absolutely,
then telling what it means, it's more complex. So yeah. But yeah, having also be able to have using computer vision is definitely something is could be very interesting and could be very useful. But then working a bit on that, a lot of question depends about your input of your video and what you want to get out. Because what I mean by that is, right, if you have someone just on a treadmill with a fixed camera, and I think that, you can quickly get a lot of information from that. If, and obviously playing with that, if you just use a camera from Real Madrid game or whatever, which is moving, panning, zooming out, then you have players moving, and then that's where you have players moving in front of each other. You have corners where you have plenty of players. You just don't know who is who, or you just need multiple camera. And that's where then, and from that, actually, it's very hard. Or from a data point of view, it's actually very exciting because there's a load of problems that, in theory, can be solved. But there's a lot of so a lot of things depends on I guess the input and what you want to get out of this. For example, just the quality of the video and if the video is fixed or not, it's huge.
Yeah. So I feel that this is like the analogy with the self-driving cars and the question of LiDAR versus just computer vision, and because there is a lot of discussion about what is better, and there is pros and cons for both, right?
Yeah, so I don't know enough about obviously self-driving car stuff, but I understand your analogy. But
so how many sensors do you guys have in the wearables?
So for now, it's just one. So they were just wearing one between the shoulder blades, so on their back, and there is a GPS, accelerometer, gyroscope, and magnetometers. So again, that's where question around what could be possible, feasible from a data point of view versus also what is actually athletes and coaches and will do, because we have one device, but also why the device is between the shoulder blades is the reason is because it's the best place for the GPS antenna. It's not the best place for initial sensors. The initial sensor would be better placed near the center of mass, but it's the best place for the GPS antenna. And since then, so we haven't moved it, but it can. So actually we've done, and actually in the same study we put also another sensors near the center of mass. Now more and more people, there's a question about also if we can only use the initial sensors. So this obviously can be placed at other places. We can use multiple sensors. Obviously that can be done. If you look at also asymmetry, obviously you can put the sensors on both legs and different places. So all this can be, and I've already done, and there's already a lot of research on those kind of things. But then it's about the application, and that's where so it's cool to be in that industry or maybe back to one of your first questions around this transition from academia to the industry. With academia, then you would place sensors everywhere, you control this, you put this in the lab, and you find some maybe very interesting things. But then again, when you just say, one of an athletes want to actually wear all that all the time? No, it's not practical. Or the question would be, why? I say, but maybe because I can even maybe tell you that you're maybe more likely to get injured. I know that. I don't care. Or, it's just, and especially if it depends about, you do have those athletes, they know their body very well, but also there are big egos as well. There are some are very well paid. So again, it's more about, and rightly so, they will probably question about why they should do that. And the more you ask from them, obviously, the more you have to give a good answer of why it's useful to them. So.
I see. Okay, so it was super interesting to talk about this. I mean, I'm not familiar with this vertical, the sports science vertical, and I find it fascinating. Actually, even more when we are talking about signal data mixed with computer vision possibilities and all the help that you can provide to to the sport industry in terms of performance, injuries, etc. So I would like to thank you for your time. It was a
Thank you very
pleasure.
much. And it was good to chat. And hopefully, we didn't chat too much about AI, but hopefully we're still around, or at least the possibilities of it in sports. So
Well,
thanks for having me.
so would you like to add something about AI in the?
Oh no, because again, this is where I think where you'll see is I feel I'm using, and again back to, or well, I know we're about to close up, but I guess a big point for me to close is to create credibility and trust and I think in sports, maybe in other domain, but you need to start kind of small, and that's why I say I don't want to go too much complex. One is because it's challenging about the data we have, but it's about explaining things to people. So actually what I've been using is from a purely data science point of view, it's I'd say basic, but it's simpler, but also on purpose. It's kind of simple, and typically I'm using a lot of still random forest because it's something I can explain to people. At least I can explain the principle behind it, and I think that people get it, and that's where then you get trust, and then this is only then you can just move on to something a bit more complex. But
Yeah, absolutely. I mean, random forest is a machine learning AI. Okay, so thank you very much for your time. I hope to see you soon, in person one day. And I hope everybody that is watching enjoy, leave comments in the video, and like and subscribe. So see you next time.